Sì, 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 sì.
Hello, everybody. Good afternoon. Am I being heard? Let me know in the chat box if I am. I'm seeing so many of you posting your name and matric number as attendance on the platform or in the chat box room. I don't need it, please. I don't need all that information you're providing. Afternoon. Am I being heard? Just let me know in the chat box if I am. I'm seeing so many of you posting your name and matric number as attendance on the platform.
But why?
Yes, you can't hear me because I stopped talking. Thank you all for joining. Um, uh, yes, someone's hand is raised. AJ, unmute yourself quickly. Yeah. Unmute and ask your question or make your comments. AJ, or was that a mistake? Okay, anyways, let me just ignore that. Okay, yes. So thank you all for joining. Once the Zoom call reaches the capacity it can take, the rest of you will be redirected to watch live on YouTube. I have also shared the YouTube link with Aminat, the course rep for zoology department. So she will share with you. You can use the question and answer box, to ask your questions. Ask your questions. Questions related to what I'm about to teach. And if you have to say anything, you can raise your hand, or you type the message in the chat box. All right, I am Dr. Adeyemi from Zoology Department. I welcome you all to your first class as Zoo 101. I will be okay. The whole course itself, it's about the mammalian body, and we're going to be taking you generally through the anatomy and the physiology of mammals. I won't be teaching the course alone. I have other colleagues who are also part of the course who will be teaching different topics, and I will only have just one contact with you. That's today's class will be the only class I will have with you, and then we'll move on to the next lecture. And once we are done, I'll let you know the next lecturer you should contact. Okay, well, maybe I should just mention that now. That's Dr. Aneyo, and she's going to be teaching you the mammalian skin once I am done with you. She will let you know the modalities for the class. You have a class by 2:30. No, I thought I was told the class starts by 3. Anyways, I'm going to have to finish this lecture before you leave. If you want to leave, it's fine, but we already had a plan to have this class for 2 o'clock today. I won't take so long. I have very few slides, and I'll be done with the lecture. All right, thank you very much. So I'm going to share my screen now, and we'll get into the lecture immediately. All right, please confirm if you can see my screen. You can drop a message in the chat box if you can see my screen. All right, thank you. You can see. Thank you very much. Thanks to all those who are responding. Okay, so the mammalian body, and I'm going to be taking you through more like a general overview of the anatomy and physiology of mammals. My colleagues who are going to come after me are going to take you, will be zooming into specifics of this anatomy and the physiology from different, different sides. But I will just give an overview, starting from the evolution of mammals, how mammals evolved, and then we'll look at key characteristics or features of mammals, or key features of animals that make us identify them as mammals. And then we'll also look at some important things that you should know, that is part of the anatomy and physiology. All right. So I want to believe that this should be an interesting course for you. Fortunately for you, we are not starting with more abstract, or would I say abstract, or maybe not abstract, but animals that are not so accessible, not so common, and not animals you come across every day or every now and then. That's like the protozoans, the poriferans, and all of that. I don't know, from secondary school, I'm sure you'd have been taught about the subkingdom Protozoa. You've taught about poriferans, coelentrates, all the invertebrates. Quite a number of them are not animals you come across every day. They're not so common. Even on television, Nat Geo Wild documentaries, you don't really come across those animals as often. Unlike mammals, mammals are everywhere, they're in our everyday life. So I expect that this course will be relatable and something, yes, you can. The course will be relatable and something you can engage with easily. All right, so just by way of introduction, mammals are the most dominant land mammals that are on the earth. And they have taken over land, taken over the terrestrial habitats. And they happen to be the most populated, the most dominant, the most present, permit me to use that, on land among all other groups of vertebrates. And they consist of over about 5,000 species of mammals on the land. Of course, there are mammals that are aquatic, like the whale is a mammal and it's aquatic. But most species of mammals, or most animals that belong to the class Mammalia, are land mammals. They are terrestrial. They are terrestrial vertebrates. Their fossil skeletons show that early mammals had very large eye sockets, which indicates, or rather means that they usually are very active at night. So early mammals were found to have very large eye sockets, which was an explanation, or rather, which scientists and fossil scientists emphasize to mean that these animals must have been very active at night. And mammals are believed to have evolved from reptiles, and this happened during the late Jurassic period. So let's look at that very quickly on this evolution scale on this next slide and see how mammals evolved. So mammals and reptiles used to share a common ancestor, which are called the synapsid ancestors. They are called synapsids. They are synapsids. Synapsids are ancestors of both modern reptiles and mammals that we see today. So the modern reptiles, snakes, lizards, crocodiles, alligators, shared this ancestor with one of the early mammals that existed. And these early mammals, which I'm pointing at here with my arrow, are called elitarians. Generally, wherever you see the term or the word therian, you are referring to mammals. So when you see eutherian, for example, just a minute, eutherian, I'm pointing at it here as well. When you see eutherian, heu means true in biology. So when you see eutherian, that means they're saying true mammals. Metatherian, metatherian here. You find protherian here as well. Please mute yourself. Please mute yourself, please. Don't disturb my class. Yes, protherian, pro means early. So, or pro means recent or primitive. Yes. So these are primitive mammals. These are true mammals, and then they're the metatherians as well. And so, but before this, before the protherians, eutherians, and metatherians evolved, the first or the earliest mammals were called the elitarians. Scientists found the fossils of these elitarians in China sometime in 2002, I believe. Sometime in 2002, they found these therians, these early mammals. And these animals or these mammals, they had a skull that looked like a shrew. They look like shrew-like organisms. They had a skull that looked like a shrew. And scientists when the fossil scientists, please mute yourself, please. Let's not make this class inconvenient and comfortable. Okay, so yes. So scientists found the fossils of this organism. This organism I am pointing out here that I'm referring to, or that is known as the Elitherian, or the early mammals, or you call them the first mammals that ever existed. And they found that this skull, when the fossil scientists checked to know when these animals must have lived, what time they must have lived, and found out that they were living during the Jurassic period, when dinosaurs were common on Earth, or found on the Earth. And so during the Jurassic period, that's how early, or that's how long ago rather, the first mammals evolved. And like I said earlier, they evolved from a reptile, or a mammalian-like reptile called the synapsid. The synapsid is a mammalian-like reptile. They evolved from that ancestor, evolved into what we call Elitherapsids. Elitherapsids. These are reptiles, basically, but they have both mammalian features and reptilian features. So we call them mammal-like reptiles because they possess a mix of reptilian and mammalian features. So let me just take it back very quickly so that you won't be confused. Mammals and the modern reptiles evolved from an ancestor we call the synapsid ancestor. And you see that reptiles began to take their own evolutionary paths, independent of the path for mammals. So from this synapsid ancestor, the Elitherapsids, which are also mammal-like reptiles, evolved from the synapsid ancestor, or descended from them. And they were the ones that now evolved or descended to become the early mammals that you see. And that early mammals were dated to live as far back as during the Jurassic period, when dinosaurs lived. So the first true mammal, that's the Elitherian we are talking about, was trying to describe, was a small shrew-like organism that must have coexisted with dinosaurs based on the fossil records that were found. And that fossil is referred to as Adrocodium, and it was found in Northern China in 2002. Of course, it's extinct, and only the fossil was found, and they found out that it had features that look like the mammals that we find today. And when they checked to see how long ago these mammals have existed, we found out that they lived as far back as when dinosaurs existed. So they were coexisting with dinosaurs. So look at the skull of the fossil of the organism that was found, and they found out that the skull looked like that of a shrew. A shrew is a mammal itself, is a modern mammal, but they found out that the skull looked like that of a shrew, with very large openings under their eye sockets. So you can see these large openings, which happens to be a feature of reptiles as well. So, and that's where it was deduced that this animal, these early mammals, must have evolved from reptiles. And these reptiles that mammals evolved from are referred to as the synapsids, or more specifically, the therapsid. And we said that this happened during the Jurassic period. If you have questions for me, rather, please don't forget to drop your questions in the don't forget to drop your questions in the question Q&A chat box. All right. So let's look at the evolutionary tree or the phylogenetic relationship of our mammals, or the evolution, or rather the relationship between all mammals that exist, and let's see, how they evolved through evolutionary time. So you can see the early therapsids here. Don't forget, I said the therapsids are the reptiles, the mammalian-like or the mammal-like reptiles that existed, that evolved from the synapsid ancestors that the early mammal evolved from. So the early therapsids were not mammals, they were reptiles. Don't forget, but they had mammal features. So they had mammalian features. And they were the group that the early mammals, that's the shoe-like organism that we talked about, whose fossil was found in 2002 in China. They are where those shoe-like organisms are believed, fossil scientists believe they evolved from these early therapsids, looking at the similarities between the features that they possessed. And one key characteristic, so you can see all these this text that is written with the arrow, this arrow at this point, or rather this dashes at this point of the tree, on the phylogenetic tree, are representing different characters that are present in this group of animals. In this group of animals. So all mammals, because are found to have a single skull hole behind their eye. So they have a single skull hole behind their eye, and it's usually very large. And they found that in the early therapsids as well. And so after that, the later therapsids evolved, and that evolution kept going until we started having the monotremes. These are mammals. These are now these are mammals, modern mammals. But they, and you can see, they evolved to have mammary glands, hair, and hair bones. And then from the monotremes, we had the multituberculates evolve. Then the marsupials evolve. Marsupials, these are mammals that have a pouch. They evolved. And they are also mammals that give birth to their young alive. But they have a pouch, the marsupials. And then from there, the placentals evolved. The placental mammals evolved. These are mammals that their young develops in a uterus with placenta, not in the pouches like marsupials. So we can see everything dates far as back as these mammalian-like reptiles called the Elytherapsids. And one common feature, or one feature that these Elytherapsids had that's similar to the mammals of today is that they had a single skull hole behind their eyes, their eye sockets that is very large. But don't forget, the Elytherapsids are reptiles, basically reptiles, but they had mammalian features. And this single skull hole is one feature that gave them that status as likely descendants, or the earliest descendants of the mammals that we see today. Are you following me? You can just answer me in the chat box if you're following me and if I'm making any sense at all. All right, thank you very much. So John, thank you. Don't forget to mute yourself when you join the class. All right. I'm not a ma. This is Dr. Adeyemi. I'm a male lecturer. Please, I am Dr. Adeyemi. I'm a male lecturer. Sorry. I don't know if my voice sounds like a lady's, but I'm a male lecturer. So yeah, thank you. Thank you, Akapu Amarachi. All right, so let's move on. So all these characters that you are seeing all these characters you are seeing increase in tooth and occlusal complexity, mammary glands, presence of one bone in lower jaw, live birth, developing pouch. All these characters are things I'm going to be taking you through. And then you would also be exposed to in the course of the throughout the course. Yes. All right, so let's move on. I think we've said enough about the mammalian evolution. Probably, okay. Let me just mention a few things. Okay, yes. So, yeah, so fossil scientists also believe that the middle ear bones, and don't forget that the mammals have ears, and their ears are divided into three parts: the outer ear, the middle ear, and the inner ear. The middle ear is where you have certain bones. There are three bones in the middle ear, and we call them the middle ear bones. And there are three bones in the middle ear. Those we'll look at that as we move on anyways. There are three bones in that, and they are the ones that receive vibrations and send the vibration to the eardrum, which is in the inner ear. So scientists believe that the middle ear bones that mammals have must have evolved from the jaws of reptiles, the jaw bones of reptiles. So this is the jaw of a reptile, and this is the jaw of a mammal. So at this point, this joint here, there's a bone in this joint. If you check that's if you check that same bone is what we now find in the mammalian ear as ear bones today. So that's another clue or puzzle that scientists found that made them infer that mammals evolved from reptiles. So don't forget the large bones, the large holes behind the eye sockets that were found in the early therapsids. Then also the middle ear bones that are similar to the ancestral reptile jaw bones. So these are characters that made scientists arrive at that conclusion or make that inference that mammals have evolved from reptiles. So let's look at main characteristics or main features that mammals possess. These are characters that you must find in a vertebrate, an animal that has a backbone, for you to be able to call it a mammal. Don't forget, vertebrates are a larger group of animals. They include all animals that have a backbone, and those include fishes, amphibians, reptiles, and birds and mammals. But mammals are more unique and more unique than other vertebrates. And these characteristics we are going to look at are the main characteristics that make mammals, that set mammals apart from other vertebrates. Number one are the three middle ear bones that we already talked about. Only mammals have these middle ear bones. We also call them ossicles. They are the malleus, incus, and stapes. Like I said, these ear bones are believed to have evolved from the jaw bones of ancestral reptiles. Another main characteristic or main feature of mammals is the presence of hair on their body. It's unique, such that no other creature, no other animal possesses hair on their body. So you find hair at least in one stage or during one life stage at least in one life stage of a mammal. Then finally, the third main feature that I find in mammals is the presence of mammary glands. They have mammary glands. These mammary glands developed from the mammalian ridges found on the skin, and they're present in both sexes. They're present in both male and female mammals, but it ceases to develop in males well before puberty. It doesn't continue developing in males, but in females, we know that the mammary glands develop, and that's where the female mammals feed their young with milk, because the mammary gland secretes milk for the nutrition of the young. So these three features are the main features that distinguish mammals from other vertebrates. But let's look at some other characteristics. They are not these other characteristics are not set in stone for mammals, but they are also unique characteristics that we have found with mammals. The presence of a four-chambered heart. So, of course, we know that birds also have four-chambered hearts. Their hearts are divided into four chambers. Simply, that's what it means. Two atria and two ventricles. Yes, and it usually ensures double circulation of blood. I don't know if you've heard about double circulation of blood. I don't know if that's part of, if circulation is part of your, if circulation in mammals is on the syllabus, I'm not sure. But you guys might, of course, you know about circulation, blood circulation, and there is single circulation and there's double circulation. What double circulation just means is that it's an efficient type of circulation that ensures that the oxygenated blood does not mix with oxygenated blood in the heart. So the heart of mammals have a section that only deals with oxygenated blood, while there's a section that only deals with deoxygenated blood. That's basically what we mean by double circulation. That's pulmonary circulation and systemic circulation. So the presence of a four-chambered heart, but not only mammals have four-chambered hearts, birds also have four-chambered hearts. And that's why we didn't list this character as a main feature. So the fact that you find a four-chambered heart in an organism that you have seen does not, in a vertebrate you have seen, does not make it a mammal. You have to check those main features for you to be able to call that a mammal. No, double circulation. Please ask your questions in the Q&A box. If not, I'll miss out on them. Okay, Nwabweze is asking, I heard dinosaurs were never in existence. If mammals evolved from them, what year were they in existence? So it's there's still, of course, there's a lot of controversy over the existence of dinosaurs. But that's not what this course is about anyways. But what I'm just going to, they evolved, they lived or existed during the Jurassic period. That's all there. But what I just want you to take from all of this is whether you believe dinosaurs existed or not, we can see similarities between ancestral reptiles and today's mammals. And it's based on that premise we believe that mammals must have evolved from. So I've answered that live. Thank you. I hope I won't miss out on that question I saw. Okay, so the person asked if double circulation, Moise Akinshola is asking if double circulation is the same thing as open and closed circulation. No, double circulation is different from open and closed circulation. Open circulation is what you have in invertebrates, mostly arthropods, and I think, yes, arthropods, and where you have blood knots within blood vessels, where the circulatory fluid is not enclosed within blood vessels, but closed circulation, the circulatory fluid is closed within blood vessels and a heart. So, of course, insects have a form of heart, but the most defining, or rather the most important feature of open or difference between open and closed is that there's blood vessels in closed circulation. You don't see the circulatory fluid when you open up the animal, except you break through a vessel that is carrying the circulatory fluid. So that's different. So animals that have closed circulation can either have double circulation or single circulation. So single and double circulation is a feature of organisms that have closed circulatory systems. I hope that's clear, Akisho. Okay, so Christian, I've answered that question already. Thank you. Yes, don't forget to post your questions in the Q&A box, not in the chat room, so that I don't miss out on them. Thank you. Okay, another feature is the presence of a postanal tail. So all mammals, yes, we have that present in many mammals, a tail that extends behind the anus. Although humans do not, they lose that tail, but it's usually present during embryonic development, but they lose the tail eventually, and it forms what you call, it becomes reduced, and it forms what you call a coccyx or a tail bone. Okay, okay, let's do this. All right, okay, I think this was numbered wrong. Okay, yes, sorry, I'm correct. Okay, sorry, the Zoom interface was blocking, or panel tab was blocking number 3. Okay, jawbone. So the jawbone, the lower jaw of mammals. So one very important, another important feature you find in mammals is that their lower jaw is made up of a single bone. Unlike what you find in reptiles, where they have two bones that make up their lower jaw, mammals usually have one bone that make up their lower jaw. Then the brain, the presence of the brain is also, the brain in mammals is a lot more complex and a lot more developed. So mammals are more intelligent than other vertebrates because they have a well-developed and highly specialized or cephalized brains than any other class of animals and even vertebrates as well. Then another feature of mammals is that they have heterodontic dentition. So they are heterodonts in this, and that means that they have different kinds of teeth. Teeth that have diverse structure and diverse function. They have different shapes, different structures, and they carry out different functions as well. And some are used for biting, some for grinding, some for tearing, and some for crushing. So let me just take you through. You see these images of different types of teeth that you find in mammals. Just a minute, please. Sorry, I had to lock the door to my office to avoid, to stop the interruptions. Yes, used, and so so you can see different types of teeth, and you see incisors growing up, incisors, canines, and premolars, molars. I know you know these different types of teeth, but mammals, yes, have that important feature to be, or property to be heterodont. So let's quickly look at a few things about mammalian teeth. Mammalian teeth have more complex shapes than the teeth of other vertebrates. Like I said, some look like cups, some look like cones, some like ridges, and these teeth differ from front to back in the jaw. So you have incisors, and they carry out different functions. They're used for different functions in the mammals: incisors, canines, premolars, and molars. And there's a complex occlusion between the teeth. So when you jam the teeth together, there's usually a complex occlusion. Occlusion means closing. The way they close together is usually very, very complex. They don't lock in a regular pattern. They lock in a very complex pattern. And another important thing to note about the mammalian teeth is that mammals have only one set of replacement teeth. And that's why you refer to them as diphyodonty, meaning that if they can only replace their teeth once. And it's not even all the teeth types that they have that have ability to do that. So they can lose some sets of teeth and replace them. But that can happen only once. Unlike other vertebrates that exhibit polyphyodonty, where you can have teeth being replaced severally, so many replacements, teeth sets. Mammalian skin is also very unique to mammals. And of course, you can see hair on the skin of mammals. See hair on the skin of mammals, You see a sebaceous gland, a very defined epidermis, dermis, sebaceous glands, like I said, sweat glands. These are then hair follicles. These are very unique and to the mammalian skin. But most important of this is the hair that grows out of the skin of mammals. So a quick run through on the reproduction modes that you find in mammals. So when we're talking about the evolution of mammals, we said that today's mammals evolved to, and you can divide them into about 3 different groups. We have the proterians, the metatherians, and the eutherians. The prototherians, the metatherians, and the eutherians. Don't forget I mentioned in the beginning of this class that when you see the term therians, it generally refers to mammals. Then the suffix that you can see, proto, meaning first or primitive. Yes. So the first mammals of the modern mammals, the first of the modern mammals, or the earliest of the modern mammals, are placed in this group Prototheria, and they refer to them as prototherians. And we generally or commonly refer to them as monotremes. So whenever you hear monotremes, they're referring to prototherians. They are so primitive in that they are the only group of mammals that do not give birth to their young alive. They lay eggs. So we call them egg-laying mammals. So have you guys heard of any egg-laying mammal before? Have you come across one before? Have you heard of one before? You can answer me in the chat box. You don't have to unmute yourself. In the chat room. No, sir. Okay, Iano has not heard of any egg-laying mammal before. Okay, well, you have Khadijat as well. Okay, quite a number of you have. Can you let me know, give an example of an egg-laying mammal? Yes, thank you, Timilade. Platypus. Thank you, Khadija. Platypus. Yes. No, snakes are not mammals, unfortunately. Monyolua. Snakes are not mammals. Chickens are not mammals. Snakes are reptiles. Chickens are birds. Yes, but platypus is a very good example. It's a mammal, but they lay eggs, and they are the only group of mammals that lay eggs, and we refer to them as monotremes or prototherians. They are in the group Prototheria. So, I don't know how many of you remember or ever watched this cartoon called Phineas and Ferb. I'm not even sure I'm getting the spelling correct. Phineas and Ferb. Do you remember? There's a platypus in Phineas and Ferb. Yes, okay, yes. There's a platypus. I can't really remember the storyline now, or the whole drama around it. Yeah, so you can just look up the Perry the platypus. Thank you, Amuson. Thank you very much. Yes, so that's a platypus. It's a mammal but lays eggs. All right, so based on reproduction, the prototherians are so we find diverse modes of reproduction in the mammalian kingdom. Some are oviparous, but other mammals, okay, so only the monotremes rather are oviparous, but other mammals are viviparous. They give birth to their young alive. They don't lay eggs. They don't lay eggs at all. So they give birth to their young alive, but there are some who give birth to their young alive, but keep them to mature in a pouch. Yes, they are born immature, and they have to develop within a pouch before they can become independent. And those group of mammals that have that that possess that feature or lifestyle are metatherians. They are called metatherians, or you refer to them as marsupials. So does anybody, can you guys give me an example of any marsupial that you know? Yes, the person that said Echinida, yes, you are correct. That's platypus as well. Yes, those are egg-laying mammals. Yes, thank you. Kangaroo, yes, kangaroos, yes. Kangaroos are marsupials. Only kangaroos. What about kaola? Kaola, bear, yes. Kaula, rather, yes. Or did I pronounce that correctly? Koala, yes. Wallabies, thank you very much. Yes, all these are marsupials. They are metatarians. They no bears are not too. Bears are not marsupials. So marsupials, which you also call metatarians, because they belong to the group Metatheria. Yes, the group Metatheria. They give birth to their young alive, quite all right. But the young is not Tasmania devil. Thank you. Thank you, Edu Mufuta. But the young is usually born immature, and they have to develop within a pouch where they will suck from the mammary glands of the mom, of the female, or of the mother. Then finally, the euterians, these are placental mammals. They have placenta that the developing embryo gets their nourishment from, and they give birth to their young alive. And most times the young is usually either precocial or altricial young. So what's the difference between these two? Precocial young is when the young is born but is not yet independent to live on its own. Sometimes they might be born without air. They might be born with some parts of their body not yet well developed for them to lead an independent life. So they have to remain with their parents, with their mother for a while until they can then, they can begin to live independently. Very good example are rodents. Most small mammals are usually give birth to precocial young animals, while the altricial young animals are those that immediately they are born, they can begin to lead independent lives. Let's see. And these young ones that the placental mammals or the euterians give birth to, usually they are still depending on milk as nourishment from their mother's breasts, mammary glands. Ademoroti, you're raising your hand. Do you have something to say or a question to ask? Why not put it in the chat box, please? Thank you. Still on reproduction, let's say something quickly about gestation periods in mammals. Generally, mammals, larger mammals or large mammals, especially herbivores, have longer gestation periods, and they give birth to precocial newborns, that is, babies that are already at advanced stage and that don't require significant parental care. Okay, sorry, I mixed that up. Precocial means that they are advanced. Altricial means that they need parental care. Yes, then whereas the small mammals, usually the insectivores, rodents, and the small carnivores, have shorter gestation periods, and their young are usually born helpless, and they require significant parental care. Why? Because sometimes they are born without sight and born airless. So small insectivores, rodents, and carnivores are usually that category of animals with shorter gestation period, and they usually give birth to altricial newborns. Of course, it's understandable why they give birth to altricial newborns, and because the gestation period within the mother is very, very short. So they've not developed all that needs to be developed for them to lead an independent life. All right, so yes, that's all. And that brings me to the end of this lecture. I don't know if I have any more questions. If you have any more questions, feel free to ask them in the Q&A section. And if there are a few of you. Okay, can I come again on the precocial and altricial? Precocial bonds are young ones that are born. They are born life, but they are born in a more advanced stage, in the sense that they can begin to survive on their own almost immediately, although they still depend on their mother's mammary glands for nutrition for a period of time, but they are born at an advanced stage and they don't need significant parental care and all. And usually, animals that have longer gestation periods, or mammals that have longer gestation periods, are the ones that give birth to precocial newborns. Whereas altricial newborns are sometimes born without sight, born without air on their body, and so they need significant parental care and cannot begin to lead an independent life immediately. And we find out that smaller mammals and then rodents and carnivores usually give birth to altricial newborns. I hope that's fine. All right, so if there are no further questions, I think we can call it again and draw the curtain here. And like I said, this is the only class I'm going to be having with you. And then you move on to the next topic, and which Dr. Neo, my colleague, is going to be teaching. Aminat, the class rep for zoology, can reach out to me for me to share Dr. Neo's number or contact with her. I'll send the slides I'll send the slides through Aminat to you all. That's fine. Don't worry yourself about attendance for this first class. It's okay. But subsequently, we're going to be taking attendance. So you should take it seriously. Moreover, this class was fixed impromptu. It's not the regular time on the timetable. So I will be a bit lenient on attendance. Yeah. Were some of you able to join on YouTube? Did it work? Can you let me know if it worked? Because I had to close my YouTube page so that it doesn't feedback. Oh, yes, it did. Thank you, Kayeto. All right, thank you. Thank you. All right, thank you, everyone. It was nice teaching you guys, and thanks for. Okay, someone is asking if whales have middle ear bones. Yes, it's their mammals. They have middle ear bones. Yes, yes. Thank you. All right, thank you all for having me. So on to your next class with Dr. Neo. I wish you all the best. See you in exams. Bye. Stop sharing now, and I'm going to close. End the meeting. Oh no, we didn't record this class. Okay, it's recording, thankfully. All right, so I will also share I think I will just share the link to the recording. Since it's recording on the cloud, I'll share the link with everybody. All right, thank you.